All right, welcome to our next example from this section. What we have is a circle of radius 4 that's centered at 0, 0. And we have beneath it a parabola, right? And we know about this parabola. We know that it's going to be opening up. If I solve for y would have been equal to, I'd move the x squared over, then divide by everything by -2. It's going to put a positive number on that x squared, and we know it's opening up from way earlier in our book. And we could get it in its standard form like we were in earlier in chapter 10 in this part of our study, but we definitely know it's a parabola and a circle. So they can intersect in a bunch of different places, right? There could be, if we look at a circle and a parabola, there could be one point of intersection, right? If it just is tangent to it. Most likely there are four distinct points. That wasn't drawn super great. So let me redraw that a little bit by putting the parabola in first and then the circle over top. Right? So it could have 2 points of intersection if it's in there, or it could look like this, right? Where there's 4 points of intersection, and theoretically it could have 3 points of intersection if it just touched at the vertex. So we're expecting multiple, but we'll see what we get. Right? Now, the worst thing to do would be to solve one of these for one of the variables, because then you're going to make it huge. Help yourself out. Take that second equation potentially and solve it for x squared. That would be the least amount of work for you. So if you had solved any one of these for x or y, in the other equation you're going to have to square that result. And if you solve for it, you'd have to deal with the plus or minus. So it's way easier to maybe take this second equation and say, you know what? X squared is simply 2y plus 8 if I get it all by itself. So what are we going to do? We're going to come in and replace that. I'll underline it in blue into its appropriate place. So now we know that 2y plus 8, and I'll type in black what's the rest, plus y squared is equal to 16. So what's that look like? That's y squared plus 2y, and if I bring over this 16, minus 8 is equal to 0. Well, again, it factors. We get y plus 4, right, times a y minus 2 to be equal to 0. So there's two things y could be. Y could be -4 or y could be positive 2. Now we're going to go find our x's. How are we going to find our x's? Take a look right up here at the blue underlined. We're going to use that number 2 guy. That's going to be the fastest way. So let's look at the y equals -4. Then we'd have x squared is equal to 2 times the -4 plus 8, or 0. Well, we know what that is. That's just a single number of 0. So we get one solution out of that, 0, -4. Out of this second one, when y is equal to 2, we get x squared is equal to 2 times 2 plus 8. Or x squared is equal to 12. Or x is equal to not just 2 root 3, but plus or minus 2 root 3. And we get two other solutions, which makes way more sense to us. And so we get a total of 3. So 0, -4 must be the base of that parabola. And that's where that circle is intersecting. But let's keep going. So what are the solutions? One is -2 root 3, comma 2. And the other is 2 root 3, comma 2. Those are your three different solutions that's coming out of that guy. And if we look at this parabola, it definitely would have a vertex point at the 4 level. We drop down a value of y being 4. So interesting, it's happening right at that vertex and giving us three distinct points, but that's how you find them. So be wise in what you do. Don't give yourself too much work. Look for ways in which you can substitute in for big things, right? In this case, the full x squared.